Okay, hello everyone. So thank you for watching this video where we'll be presenting the app that we implemented for the Redis vector search hackathon. I'm here with my teammates, Ariel, Armand, and Robin, and we are glad to present to you the app we implemented. So our app is called the Darwinian Paper Explorer. I will be explaining very shortly why we chose this name. Just for the technical background, we have deployed our app on Saturn Cloud, and of course we are using the and leveraging the Redis vector search capabilities for our paper search. And in terms of the data we used the arXiv dataset, but we also decided to complement this data with the semantic scholar data. Actually, we used an API to retrieve citations data about the papers from Semantic Scholar. So those are our two main data sources. So our app is called the Darwinian Paper Explorer because vector search gives you, for a given topic, the similar papers, but we also wanted to add an additional dimension to this analysis, where not only we take the most similar papers, but we only want to see what is the evolution of a given topic throughout time, and also see the evolution, for example, how we go from one founding paper to other papers that will be built based on this this founding paper. So let me walk you through our app. I'm sure this concept of evolution would be more clear to you, would be clearer to you. So here we have our search parameters. Let's say we want to make a query about the attention mechanism. Let's say we want to take the 60 most similar papers based on our query. And we can also specify the upper and lower bound of our dates. And finally, we can select categories. Here, based on some technical bottlenecks, we only decided to include in our database data science related categories. So here we have 5 categories, and also because we are data scientists from Artefact, we thought that it would be easier for us to analyze our results and analyze the relevance of our app on data science related topics. So here we will leave this field empty, and we can click on submit. So here, upon submission, the app will retrieve the similar papers, and it will first produce a topic trend graph where we have the evolution of a given topic from 2015 to 2022, and we also have the predicted evolution for the next 2 years based on some simple exponential smoothing. But here the idea was really to say, okay, this is what we think will be the direction of this topic in the next 2 years. So basically, it's the papers count per year, and this gives us the evolution. And here, as attention, the attention mechanism is quite popular and has been popular in the past years. We can see an increasing trend. Let's say we take another topic. Let's say we choose boosting. Here it's taking some time to retrieve the query results. So in the case of boosting, it's quite different. Here we can see that globally the trend is decreasing, and that's also what we see for the prediction. And so having this trend can also help us see what are like the most trending subjects and what are maybe the less trending subjects, even though here boosting is also a quite popular and relevant machine learning method. Next, what we can see here is the topic evolution. So here it's in the same idea of this evolutionary process, but here we show our papers as nodes in a graph, in an arc diagram graph. Each point here has a given size that is based on the number of citations. The papers are ordered in a chronological order here between 2015 and 2022. And finally, we have the links between the papers that are actually citations link. So, for example, here we can see that the two most influential or like founding papers are XGBoost and CatBoost. And we can see that a lot of papers that came after are actually citing XGBoost or citing CatBoost. Here, when we hover over a given point, it gives us some more information, but also, let's say I want more details about XGBoost. If I click here, it will take me to a detailed list of all the papers that we have. And also, let's get back to XGBoost. If I expand this here, it will give me some information about the paper. So the authors, the publication date, the number of citations, the similarity, the abstract, and I can also click on the link here, and it will take me to the arXiv link of the paper. So here, the idea of this graph is really to see what are the most influential papers, what are the founding papers, and also what are the relationships between the papers, and what papers are built upon what other papers. Also, we also implemented a reading list recommender. So basically, here what we say is, let's say you want to read 3 papers about this topic. Here are the 3 papers that we suggest. This suggestion is actually based on a similarity score and a number of citations. So basically, we here, for example, we suggest 3 papers. Here we find XGBoost and CatBoost, which are very popular boosting algorithms, and we also have a paper that is explaining some other boosting techniques like AdaBoost, but also a bagging method like random forest. And just as a detail here, so and as a complementary information, the papers are chosen based on the similarity score and the citations, and actually it is the multiplication of the similarity score by the number of citations that gives us the top. For example, here it's top 3 papers that we suggest. And here it's the same thing. If we click on a link, it will take us to the detailed overview of the paper. And yeah, here finally we have the paper's overview that is ordered by similarity, where we can look at the details of any paper and go to the paper. Okay, so that was it. Thank you very much for watching this video and taking the time. And if you have any questions, do not hesitate to reach out. You will find more technical details in our README file in our Git repository. And yeah, take care. Thank you very much.